Hey, you guys, we don't have time for this. We got to get to work. Remember, it doesn't matter what I do if you don't do the work. It makes no difference. Okay, Jack, put your phone away, please. It was good. This is 2008 non-calculator.
So with infinity over here, like, would you just like multiply that out and like when infinity ignore all of them until you get
Because they're polynomials.
yeah.
Okay, this is a horizontal asymptote. Okay, shh. You can work other problems. If you got this, great. Work other problems then. But when you multiply this out, this is going to look like the limit as x goes to infinity of negative 2x squared plus some other stuff. Now, these are polynomials. I don't care. These are polynomials, so they're easier. But if they're exponentials, they're not easier. So this is x squared, etc. As x goes to infinity, this is going to look like negative 2x squared over x squared. It's going to look like y equals negative 2. So the answer is B. You have to multiply it out. 2008, number 1. Are you in the non-calculator? I mean the calculator one? This is non-calculator. And the calculator one, you probably haven't done, but you should. So for Monday, do the calculator one. I don't know if there's limits in there. I'd have to look. I gave you a spreadsheet that said where all the limit problems are. Oh, maybe I didn't. I'll have to find that. Answer's B, negative 2. Well, yes, you do, because you did this Monday. Were you gone Monday? We did it Monday. You should have a Scantron, although I didn't get yours. So now I will put up, and I haven't done it yet. I have this. Videos from this class and from the other class. Uh-oh. I might have to get that back because I don't think I have another one now. Oh, there it is. Okay. Now, the other class asked about number 3 because they found that hard. Where's your packet? Well, you don't know if you got it right or wrong. Number 3. This is still the same packet. We're just in 2008. It's not. It's a derivative. Now, we're going to talk about some test-taking strategies here. You don't have to finish the problem. Now, for me, when I'm going through the year, I want you to show me all the work, etc. Because I'm trying to figure out if you know what to do. When you're on the exam, that's a different ballgame now, different rules. And so if you can figure it out, fine. We want the derivative, and that wasn't the problem. It's x minus 1 times the derivative of the second one, which is 3, x squared plus 2 to the second power times the derivative of the inside. Plus, then it's x squared plus 2 cubed times the derivative of the first one, which is 1. Products rule. Remember the products rule? Yes. Is what? This is times 2x. There are no decimals in this. So it's times 2x. And if you look at the choices, that doesn't look like any of the choices. We didn't do any problems like this. In our old book we did, but in this new one we don't have it. But what we're going to do, instead of multiplying that out, which is way too hard, and then if you look at your answers, they're factored, we're going to factor. We're going to take out a greatest common factor, which is x squared plus 2. What's the most you could take out of that? Squared. Okay, so that's what we're going to do. You don't have a lot of practice. I don't know You know, this was a tough problem. If you're not algebraically, if you're not thinking to factor, if you're thinking to multiply, then it's harder. Okay, so I'm left with 3x minus 1 and 2x from this one, and I'm still left with plus x squared plus 2. I don't have to do any more work. Look at your answers. We have now ruled it down into what? C or D. Okay, Jack, put your phone away, please. And is it x squared or is it 7x squared? Just look here, Scott, which is it? Is it going to be x squared or 7x squared? If you were to multiply that out, I'm not going to waste our time multiplying it out. I got it down. It's either C or D. Which one is it? It's D. Okay, these are test-taking strategies. It's D. Do you need one too? If you can get it, well, first up, there's no penalty for guessing. So that's kind of nice. There used to be. Well, yes. Then you had to think about it. Let's do number 5. There's no penalty for guessing, so don't leave anything blank. It's kind of nice. Okay, number 5 is on page 22. It's the limit. You need to be bringing your packets because that's what we're going to be doing. You don't need your book anymore. Well, less you need it for reference. There's 2 ways to do this problem. You could factor it. Remember, that's all that's required for your this course, or you could use L'Hopital's rule. Yeah. It only applies, that only applies when you're talking about polynomials. That's why I don't like it. These are polynomials. So I really don't care about these terms. I'm thinking through the problem. It's too much memorizing. Think it through, and you can see that the x squareds will cancel. If this were x cubed and that were x squared, then it would be infinite. No, only infinity. 0, what do you do when you get 0? You put it in, right? You substitute in. If the limit's approaching a value, a finite value, substitute it in and you get what? 0 over 0. Now, we either factor it to get rid of that 0, that's where the 2 factors are the same in the numerator and denominator, or we can use L'Hopital's rule. In the other class, we use L'Hopital's rule. Which way do you guys want to go? Okay, it takes more than one try on this, by the way. Nope, you can only do L'Hopital when you have a ratio of 0 to 0. Has to be a fraction. This particular one is 0 over 0. So it's 20x cubed plus 16x over 12x cubed minus 32x, right? Put 0 in, what do you get? 0 over 0. Do you think you can do L'Hopital's rule again? Yeah.
Yes.
I think it might be easier to factor this, but maybe not. You have to do this one twice. But you always must check it after you do it. That's one of the problems here. This is 60x squared, 36x squared, plus 16 over negative 32. Substitute in 0, and what do you get? 16 over negative 32, or negative 1/2, which is, what answer there? A. We're not taking the second derivative. We're taking the derivative of the numerator divided by the derivative of the denominator. It's not the quotient rule. I had to do it twice. If you want to think of that as the second derivative in each piece, yes. But I just think of that as you started with this function, you took the derivative. I'm sorry, what? Could you have factored out x squared? Yes. I think that's easier, but L'Hopital. L'Hopital is French mathematician. Sometimes it's spelled a little different. Oh, okay. Let's do number 6. We haven't talked about continuity, but let's do number 6. Just a little bit. And that's over x minus 2, and that's 1. Okay. What I do with these, 1, 2, and 3, I look at each one of those and decide individually if it's true or false. Then I go down here at the answers, okay, to see which ones I'll pick up. So part 1, f has a limit. If f has a limit, the limit from the left has to equal the limit from the right at x equals 2. So what is the limit as x equals 2, as x goes to 2? That's x squared minus 4 over x minus 2. We did it yesterday, but let's do it again. You want to use L'Hopital's rule or do you want to factor? L'Hopital. Because that's what? 0 over 0. So using L'Hopital's, I'm going to get the limit as x approaches 2 of 2x over 1. So that is what value? 4. Does the limit exist? Yeah. I don't care what happens at that point. Okay. It would probably be x squared plus 4 over x minus 2 be a vertical asymptote. You would have some number divided by 0. Or it could be the one with too many wiggles. I don't think they're going to do that, though. But just so that you're aware of that. So the limit exists, yes. Scott? We can factor this. This is x minus 2. Because I like the factoring because you see what happens. The L'Hopital's rule is a trick that you don't know why it works. Here are the zeros. When I put in 2, that's where I get the 0 over 0. But remember, for limits, we don't care what happens at 2. We only care what happens when we're near 2. So as long as we're not at 2, I can go ahead and divide those out. So this graph looks like this line. It actually looks like this. X plus 2 is a line like this until I get to 2. And guess what? There's a hole there. If it's 0 over 0, it's going to be a hole. And there it is. And what value is this getting close to? 4. If you put on your graphing calculator, you can see the hole, provided you do a zoom decimal. Okay. Well, is it continuous? Not just, you don't even have to know the definition of continuity here. Is it continuous? Look at that. No, number 2 says f is continuous at x equals 2. Part 1 is true. Is part 2 true?
No.
Well, be careful. Where is this filling this one in? No, it isn't. It's filling it in. When x is 2, it's putting it in at 1. So is it continuous? It's not in the right place. No. So that's false. Okay, girls, you got that?
So anything with a 2 is in an option is false. So you will B, D, and E.
Well, I'm not doing it that way. I'm going to rule out 3 because can you find the derivative if it's not continuous? No, that's what differentiable means. I haven't reviewed it, but part 3 is false. So the only one that's true is 1. So that answer is A.
Okay, wait. Just quickly, from number 1, the answers are.
You have answers online.
Yeah.
Answer 1 is B. Oh, I don't know the answers. Mine's blank. I have to do them.
Make sure you hand me your blank pack. I'm like, yeah, I already have these done. Right? Even the one you said.
Good. Okay.
Number 9.
Well, I want to get to 19. We were at the end of class yesterday, and that really is an important question. Number 9 is going to be an area.
It's going to be a different way.
Why don't we do that a little bit later when we do max mins?
But okay.
I want to get through topics, and we will come back and do those. But how do you know if a particle is at rest? Velocity is 0.
And the acceleration.
Okay, that's going to involve the fundamental theorem of calculus. I'd rather do that when I review FTCs. Okay, so when we skip ahead, I think it's 19, and that's the one they threw out. So there aren't going to be a whole lot of limit problems, but 19 is a limit problem. This is 19 on page 30. We started it yesterday, but you guys were anxious to leave, so I don't feel comfortable with where I left it. You were it. Okay, here's the problem with this one. Yes? No? Not unless you want a final. We'll be doing some assessments on these free response questions. Or maybe on multiple choice too, because we are very weak on multiple choice. If you were looking for a horizontal asymptote, you're looking for the limit as x goes to infinity. Now, I'm going to do this a little differently, but not that much. Why don't we just put in some numbers? Let's put in 100. Because it's a horizontal asymptote. Horizontal asymptotes are always the end behavior. Think about what it means. I don't care what's happening here at the origin. I just want to know what happens out there. But, and some of you think that if you have a horizontal asymptote like here, you'll have the same one over there. Not true. It says in the question. Okay, so let's let x go to infinity. So let's try x equal to 100. Let's just use some number sense. It's 5 plus 2 to the 100 over 1 minus 2 to the 100. Do you really care about the 5 and the 1? No. So that looks like 2 to the 100 over negative 2 to the 100. If you don't see that that's negative 1, I can rewrite that since they have the bases, same basis. It's 2 over 2 to the 100th power. What's 2 over 2? 1. 1 to the 100th is 1. So this is negative 1. Evel, you need to be focusing because... Okay. So this is y equals negative 1. Well, that was the first choice. So what happened was, I think students said, oh, I'll just look at either positive infinity or negative infinity. And so they found one of the two answers. You need to read through all the answers because you can't just look at positive infinity. You must look at negative infinity. That's kind of where we were yesterday. So it's the limit as x approaches negative infinity of 5 plus 2 to the x over 1 minus 2 to the x. Now this could be on the MCA. What do you do with negative exponents? Let's let x equal negative 100. Then it's 5 plus 2 to the negative 100 over 1 minus 2 to the negative 100. What is 2 to the negative 100? It's 1 over 2 to the 100th. Yeah, well, why? Because what is that limit? Right. And this is one of the limit properties that you may bring your limit through the whole problem and take the limit of 5, and take the limit of this one, limit of 1, and the limit of that one. You're doing it automatically. But there's a limit property that says you can do that. And so this is going to go to 0. This is going to go to 0. So I do have another asymptote, and it's y equal to 5. If you don't believe me, graph the function. These are exponentials. They don't behave like polynomials. And everything you did in pre-calc was probably polynomials. So you have a false feeling of security there. It's just a random number. I wanted to get far away from the origin because I know 2 to the 100th is huge, right? I mean, I could do a million, 2 to the million power. I still get the same answer. Because this is 1 over 2 to the millionth power. So 1 divided by a huge number is 0. That's your chances of winning the lottery. What? You always have to look at the limit as x goes to infinity and x goes to negative infinity. As x goes to some c value. Right. Okay. I'll see if there's any other limits in here. Oh, there's a good one. We can't do this quite yet. So let's look at our packet. We want to look at 25. Same packet. I'm just going through it. Now, I went through yesterday all of page 1 on your ivory packet, and I they pretty much did almost all of page 2, but they didn't do continuity. And we have to know continuity because it's been a free response question. And if you don't know what it means to be continuous, you can't get the points for that. Yeah, tell me what it means to be continuous, Alex. The limit as x approaches c of f of x has to exist. They're in here. You can't hardly read it because the limit of f of x, oh no, that has to also be true. F of c, no, f of c must exist. In other words, you can't have a point missing in your domain. Both sides has to equal f of c. No, you can't write it however you want. You have to write it like this. Okay? Now, on a multiple choice, I don't care. But on the free response, hey guys, they do care on free response. And we could go and look at 2000, I'm pretty sure it was 2012. So that's what you mean to be continuous. Now, let's get another word in here. Let's get differentiable in here. Now, by the way, when you say the limit exists, you really have to do this. The limit as x approaches c from the left of f of x has to equal the limit as x approaches c from the right. That's how you justify your response. You're going to have to state that on the exam. Okay? Patrick, okay? I'm going through all the highlights. These are the essential things that you need to know. The video's only backup. You really need to be with me now because you can't ask questions when you're looking at the video. Hi. Yeah.
Oh, I was just at one of those. Yeah, it was resolved. I already signed up. It was just a mistake.
I'm going to kind of jump around here a little bit. These are the main limit laws. You're already using them. The fact that you can distribute limits, or you can take limits inside of square roots, but you're already doing that. When you substitute in, that's what you're doing. And that's theorem B on the next page. Substitution theorem. You just substitute it in. Okay. Don't worry about the squeeze theorem. We don't have to know it.
What is the squeeze theorem?
Well, I might not be right on that one. The squeeze theorem well, you're not going to have to prove anything, but you may have to use the thinking. Just says that if you have two functions, there's f, there's g, and then here's h. If h is trapped between f and g at this c value, all those limits will be the same.
Yeah.
Yeah, so you already know that. It's logical. So the limit of h as x approaches c will equal the limit of f and the limit of g. They're all going to be the same if it's trapped between there. And I can use that to prove things. We'll do a lot more of that in BC next year. So it's not too big a deal. Next page talks about what functions are continuous. Sine and cosine are continuous. Polynomial functions. What's a polynomial function? X squared. It's x to the n, where n is a whole number. Not, you can't do decimals, you can't do fractions, you can't do negatives. This way?
I'll put it to you this way. They said you can't divide by zero.
No, it's not defined. No, it's not defined. It's infinity. Not defined. Okay. Make sure you notice, which functions are continuous. It saves you a lot of trouble if you know. And you just draw the picture. If you can draw the picture without lifting your pencil, it's continuous. Okay, Jack, Carter? Okay. Now, differentiability. Do you remember where functions are differentiable? You remember what differentiable means? Yes. You can find the derivative. Okay. Where do we have problems? It's not differentiable where? Because they're going to ask you, this is a guarantee. They're going to give you a graph and say, where is this not differentiable? Sharp corners. Because a derivative is a limit. So if you take the absolute value function, for instance, and you try to find the slope on the left side, this is -1, and the slope on the right side is +1. And when you have a differentiable function, this has to smoothly go into the other one. It doesn't. This is like backing up your car in reverse and not stopping and shifting it into forward. Not a good thing. So they have to be the same for both sides, the derivatives. So if you have a sharp corner, this is not differentiable if these two numbers aren't the same. Basically, it has to go to 0. Okay? Yes. This isn't any problem. It's in your packet. Differentiability. Do you have to have a continuous function?
Yes.
Okay? Discontinuities are issues. Now, those we grab pretty fast, by the way. But there's one other one. Where else do we have a function that's not differentiable? Vertical tangents. Because what's the slope of a vertical line? Not defined. So if I take this graph here, this is a vertical tangent. They'll tell you it's a vertical tangent. You don't have to guess. So I can think of the problem. I don't know if it's in the 2008 exam, but it probably should be. Okay, so let's do some problems. Oh, by the way, too many wiggles is another problem, but you're probably not going to run into that. Now we can come back into our 2008 packet. Too many wiggles would be the sign of 1 over x as x goes to infinity. Yeah, you can't get it to go to one single point. That's what it has to do. Okay, so we're going to pass 19. Oh, I have it over here. Let's do problem 25. Yeah, that's the reason why I'd rather you take notes, but I don't know. Okay, let f be the function defined like this. F of x is equal to cx plus d, x squared minus cx. See, the problem is, I don't think you have any problem knowing what's differentiable. The problem is deciding what to do on a problem. So you have to know the concepts so that you have some idea what to do. So it says f is differentiable at x equals 2. What does that mean? F prime of 2 what? Exists. Matter of fact, f prime of 2 from the left and f prime of 2 from the right must be equal. That's the key thing right there. So when I'm doing the problems, I think, well, what does that tell me? That tells me something. Okay? What does that tell me? And then it says, what is the value of c plus d? Find c plus d. This is differentiable, that tells me a whole lot. What about continuity? Carter, what about continuity? You need to be doing this. You think 4 weeks is a lot of time? It's going to take me 4 weeks to get through all the material. It's a whole year's worth of material. Only because I'm reviewing it, I'm expecting that you once learned it. Not for the first time. No, no, no. Okay, if it's differentiable, what's true about the continuity? It's continuous. So it's continuous because it's differentiable. So it's stronger. It's a very strong word. It got me. Continuous. There you go. I know. I hate wasting time fixing things like that. Continuous. Just a spelling error. Okay. That means the limit from the left has to equal the limit from the right. Well, the only way to find C and D is to maybe write some equations that I could solve. Do you want to do the derivative first, or do you want to do the continuity first? Yes, do both. Derivative first. Okay, so let me move this up here. What is f prime for x less than or equal to 2? Let me write it up this way. If this were a free response question, this would be a good way to write it. I want f prime of x for x less than or equal to 2, x greater than 2. You're not going to be used to the problems that you're going to see on this exam unless you practice them. So what's the derivative of this one? What's the derivative of that? It's just c. What's the derivative of this one? 2x minus c. Now, on the left side of 2, it has to equal the right side of 2. So c has to equal 2x minus c at what value? X equals what? 2. So c equals 2 times 2 minus c. Can you find c? David, can you find c? You got to practice this. If you don't get it while I'm doing it, you got to ask. That's why we do study sessions. It's still not enough in class, really. Add c to both sides, so 2c equals 4. So c equals 2. It's just not that bad. But you have to know what differentiable means. And maybe there's a place in your notes you want to write down things that are important. Differentiable always gives you continuity. So now I have to do the continuity piece. So the function from the left, what is this function going to from the left? What's the limit as x approaches 2 from the left of cx plus d is equal to what? Put in 2, always substitute, 2c plus d. What is the limit from the right? Limit as x approaches 2 from the right. I'm going to use the other formula of x squared minus cx. Yeah, I must watch my time a little bit, though. What's my time? I mean, I get through everything, but we'll see what we can do. So you have to find the limit from the left side and the limit from the right side, following the rules they give you. And so what's this equal to? If I put in the 2 here, it's 4 minus 2c. What do these have to be? They have to be equal. So I'm going to write that down here where I have some room. 2c plus d. But we know something, thank goodness, is equal to 4 minus 2c. But what's c? It's 2. Can you find d? It's a multi-step problem. We're just taking what we have and we're working on it. Andrew, you can do that at home. I don't go home with you. So it's 2 times 2 plus d equals 4 minus 2 times 2. So 4 plus d equals 4 minus 4. Oh, it's 0. So d equals negative 4. Don't forget to answer the question. The question asks for c plus d. So it's 2 plus a negative 4. Hopefully I didn't make a mistake. Negative 2, is that an answer? Yeah, it's B. Notice that they have negative 4 as an answer, and they have positive 2 as an answer. Yes, those are distractors. That's a nice little problem. That's all of, yes, that's all of the non-calculator one. Now let's look at the calculator one and look at some limits. Number 77. Oh, this one's easy. Then what could you do close to the exam? Take the 2008 multiple choice exam and rework it when it's all mixed up. That's calculator part. I don't need a calculator for this. I'll let you find it, I'll draw it. Take me a second. Well, I gotta draw it. I don't, Well, you know what? You didn't do this one because Mr. Winterhalter gave you the wrong packet. He did 2003. Okay. The figure above shows the graph of f, domain 0 to 4. If they give you the domain, it's really nice. Which of the following statements are true? 1. This is still 2008. I don't want to confuse you, but we've switched to the calculator one. And we're going to really work on the calculator problems because they're not easy. This one's not bad. I don't need a calculator for this one. It says the limit as x approaches 2 from the left of f of x exists. Unless you're talking about too many wiggles, one-sided limits are going to exist. Or vertical asymptote. I don't see a vertical asymptote. I'm just copying the problem. I'm not really doing anything. Part 2 says the limit as x approaches 2 from the right. This is multiple choice 2008 calculator section. They start at 76. You got this yesterday whenever I handed out the stuff. Yeah. Exists. I've got more. If you don't have this packet, you should have gotten it yesterday. I got a bunch of these. No, I gave it out yesterday because he gave you 2003. Whoops, that's no calculator. I wish they had been different colors, but I know the BC is all in different colors. Okay, if you don't have it, looks just like the other one. And then the third thing is the limit as x approaches 2 exists. What? Yeah, unfortunately, that's not a good thing.
I know.
Okay.
He's putting me out of my business.
You guys, for the third one, what has to be true? The limit from the left has to equal the limit from the right. So let's find the limit from the left. As you approach 2 from the left, we should have gotten yesterday. Does it exist? Sure. It looks like it's going to 2. Right? It's a one-sided limit. No, we don't care about what happens. And that's a good question. We don't care about what happens at the point. You can have a hole there, you can have a dot there. It makes no difference. No, because we don't care what happens at C. Because what is a limit? It's what is the y value getting close to? Getting close to that number there. I made it too. There's no number on your packet, but you can see that it's getting close to a value. Remember, one-sided limits will exist unless you're coming into a vertical asymptote or you're getting too many wiggles. What about from the right? Andrew, what's the limit from the right? It's 1. Does the limit at 2 exist? No, because 2 does not equal 1.
Seems easy enough.
So only this is true. This is true. 3 is false. So you have to do 1 and 2. I think this is easy, but you have to know about what a limit is. It's what's y getting close to. I don't know if there's any other limits on here, but we will. And we'll try to make sure we get through all these multiple choice questions, especially ones with the calculator. That's why we're reviewing. 89 is related, but I can't really do that. And number 90 is very hard. It's very hard. So is 92. Let's look at 2012. There's a free response question. Now, you should be working on these problems, all of them. And we've done differentiability, and we've done continuity and limits, and I'm going to run out of time. 2012, I need to find, though. Are they still back there? I think they're back there. 2012 free response. I believe it's question 1. If you were absent, I got more back here. 2012, I believe there was one that had a continuity piece in it. I may be wrong.
Okay, I got it.
Oh, 4C. Our feeling was if you can't do 4, you shouldn't get the credit because there's nothing fancy on 4 in 2012. There's nothing to read. It's just like your textbook. 2012, number 4, and we're going to do C. Okay. It says g of x is equal to f of x. Well, f of x is this. Does anybody know what that graph looks like? Yeah. It's a circle. That's a circle. And here's x plus 7. I copied this wrong. That's negative 3. And I suppose you could graph, but it says use the definition of continuity. So is G continuous at x equals 3? Negative 3. Well, how do you know if it's continuous? First, you have to find G of negative 3. Does G of negative 3 exist? Put negative 3 in there. It's the square root of 25 minus negative 3 squared. So that's the square root of 25 minus 9, which is the square root of 16, which is 4. Okay, there are 3 parts to continuity. But it's only going to go from negative 5 to negative 3. Okay? Yes, it is. It's just not a square picture. Zoom it square and you'll get a circle. Yep. This is a non-calculator problem. I don't even care if I know if it's a circle. Now, the value of the function exists at negative 3. What else do we have to know? We have to find the what? The limit from each side. Okay, girls? I need to find the limit as x approaches negative 3 from the left of this function of g of x. Is that equal to, and writing this will get me my points, negative 3 to the right of g of x. They're going to look for that. Okay, everybody got that? Oh, your job is to find the limit from the left and the right and tell me if it's continuous for tomorrow, Monday. Okay, it's continuous. I believe, isn't it?
It's not.
Yes, it is.
No, it's not a circle. I've done it. Look, we agree that's the equation.
It's a circle.
You grab it.
Yeah, well, you know what? The tangents are vertical there, so the calculator doesn't know what to do.
Fair enough.
You can't believe you're graphing calculator.
Make the circle and it wouldn't make a...
Well, you got to get the other half. That's just the top half. So the limit from the left is 4, and the limit from the right is 4. Yes, it's continuous.
And then I have a question.
Because that limit, which exists, and you have to give it a value of g of x, equals g of negative 3. Done.
Question. It's not really math.